Hi, Assalamualaikum warahmatullahi wabarakatuh. So today we are going to present about our assignment one for the subject of microprocessor. But before that, let me introduce myself. My name is Hamizi bin Osman, and my group leader is Awanku Izzat and Awang Jaafar, while the other colleague is Muhammad Daniel Aiman bin Rosli.
Hello, so I will explain about the coding of the C programming on this project. So the top here it is all the includes that we need to do for all the tasks given, and then here's the declaration for num A, num B, and also outcome for the task 4. I will explain later. So here's the for the delay function, delay ms. On this function we use for the for method, looping method, and then here is the delay 250 millisecond by using timer 0. You can see the timer count equal to 255 minus 243, which is we will start on 12, and the TCCR here used for to set the prescaler equal to 1024. And then here is for the detection of the OV0, is the overflow. When the overflow is equal to 1, the image it will repeat back to 0, and then we clear it, the TOV0 to 0. And then here's a delay 175 millisecond using timer 0 function. And also the same as the previous one. Okay, and then here's the function declaration for the calculation operation on the task 4, which do addition, do multiplication, do subtraction, void do division, void swap data, and also void display. Before I explain more about this function, let me just proceed to the main function. Later I will tell you about the function for the task 4. So here's our main function. We set DDRA equal to 0, which is our input for the data on task 4. Here's a DDRC. The DDRC we set as 0 XFF, which equal to 1 for the output on the LED display. And here's DDRB for port B. We also set it as FF, which is equal to 1, to set the port B as our output for 7-segment display. And the last one is the port D. DDRD is equal to 0, which is our input, which is for the switch, and the port D is equal to 1 to enable the pull up resistor. So we enter the loop while 1. So if our pin is equal to 1, or switch 0, SD0. So on task 1, we need to, for task 1, we need to display running like delay on port C. So here's our coding. We sign the port B is equal to 0. Is no on the 7-segment display is nothing appeared. And for port C on bit 0, and then we put delay 250 millisecond function delay as asked from the question, and then port C on bit 1, the LED will blink, will turn on, and then for bit number 2, until bit number 7. And then we repeat again until bit number 7. So it will keep repeating. And then we move to task 2, where the task 2 we need to display blinking LED delay on port C. It is different bit from the switch 0, where it's running like with delay. So for the second one, so for the task 2, we design our own pattern on the LED, which one will turn on and which one will turn off every time the LED will turn on. And the first one, we choose to turn on the bit 7, 6, 0, and 1, and then there is delay. And then after that, the bit on 2, 3, 4, and 5 will turn on while the others are turned off. And after that, the bit on 3 and 4 will turn on and the others are turned off. And after that, the bit on number 2 until number 5 will turn on. And the last one, the port on C display on the LED, the bit on 0, 1, 6, and 7 will turn on. And the last one, the LED port will not display anything, as we assign the port C equal to 0. And then we move to the task 3, which asks us to display the number IC of the group leader, which is me. So here we display the 7 segment display on the port B. So we choose the port C equal to 0. So for the IC number, the first one is 0, and then delay, and then 0 again, 0, 1, 2, 0, 1, 2, 0, 5, 6, 9, which will appear on the port B as long with the delay time we choose here. And after the last number, which is 9, display on the 7 segment, the port B, which means the 7 segment display is not display anything, and then it will keep repeating again and again. So that's all for the task 3. And last one, which is the most difficult one, which is the task 4. So when the pin D is equal to 8 or SD3, before that, let me explain about the function on task 4. The function that involved in this task. So as from the starting of this video, I already talked about this one. And then here is the function for swap data, void swap data void. There's no value to return or taken or given. So we assign the num b equal to the pin A, and also the num A is equal to pin A, because the question asks us to assign the num A and num B is on the pin A, which is the 8 bit. So the first one, num B, is assigned to 00F, which is on the right side, 1111. You only need this side only, where the num B is assigned for the bit on PA3 until PA0. And then for num B, which is, num A, which is on the bit for PA7 to PA4. First, we shift. First, we assign the value for the 4 bit on num A equal to 1, and then we shift all of them by 4 bit to the right, so that we will get the same position for num A and num B, which is on the lower side, the 4 bit number on the lower side. Okay, and then we move to do addition function, where first we call the function of swap data, and then, but before that, let me explain on the display function. The display function we use to display the result of the outcome of the mathematical operation for the input num A and num B. We display it on the port B as sign from the equation. So here is the function display. So if outcome equal to 0, the number on port B will, will show 0 on the segment display. If the outcome equal to 1, the segment display on port B will show number 1. So it will keep going until 15 is there. If the number of the addition of the process mathematical operation between the num A and num B will get the result or outcome equal to any of this number, it will shows display the result at the 7 segment display based on what value it will get from the mathematical operation. And then after that, the 7 segment display will disappear after we assign the port B equal to 0. Okay, let's move for the mathematical operation function. The first is do addition. So the outcome is equal to num A plus num B. So the num A plus num B, and then will goes to the value for outcome, and then the display function is called. So we go to display and we look on the outcome value, then it will shows the value of the outcome in the 7 segment display. And then do multiplication, where the outcome equal to num A multiplied by num B, and then subtraction, the outcome equal to num A minus num B, and the last one is the do division, where the outcome equal to num A divided by num B. Okay, and then on the port, on the task 4 here, so it will enter, and then the function of do addition is called. So we go to the do addition function, and then display, and then it delays, and then go to do subtraction, and keep going to do multiplication, and also the last one is do division. So, and then the port B equal to 0. So that's all for the task 4. And if else, if the pin D is not, the value of pin D is nothing on the rules, the condition on the pin D that we assign here, it will turn the port B and port C equal to 0. And then that's all for the coding of the project. Thank you.
Right, so for the task one, we are required to display the running light with delay 250 millisecond at LED at port C by using loop technique. So that means we need to switch on the switch at SD0 at the microcontroller view, while the other switch will be switched off. Right, so as you can see from the 7 segment display, there's nothing appeared, while at the LED board, the LED is blinking sequentially and repeatedly. That means the LED is blinking from port C1 to port C2, port C3 until port C7, and it goes back to port C1 and repeat the same thing. Right, so for the task one, we are required to display the running light with delay 250 millisecond at LED at port C by using loop technique. So that means we need to switch on the switch at SD0 at the microcontroller view, while the other switch will be switched off. Right, so as you can see from the 7 segment display, there's nothing appeared, while at the LED board, the LED is blinking sequentially and repeatedly. That means the LED is blinking from port C1 to port C2, port C3 until port C7, and it
Assalamualaikum warahmatullahi wabarakatuh. My name is DANIAL bin Rosli, and today I'm going to simulate to you the result when the switch at SD1 is pressed. So, little disclaimer, this is a pre-recorded video, so I will play the video and we can see the result. So, from here we can see that only switch at SD1 is only on. So we can see top and the center. So it will display the pattern like this, and it will go back to its original pattern. So in the middle and at the top one. So after complete this cycle, it will play once again the same pattern. Yes, so we can see the top and in the middle, so there will be only two in the middle, and same, it will go back to its, yes, this is the pattern for the blinking LED for our group. That's all for me. Thank you. Next, I will simulate to you the result when the SD2 is pressed. Technically, it will display our group's leader IC number. So I will play the video. This is a pre-recorded video, so I will play the playback speed. I will increase it, so the speed will be much faster. So you can see 1 2 0 0 1 0 0 1 2 0 1 2 0 5. It will display a 12-digit number because according to IC. So it lasts with the digit 9. So next it will display, it will repeat the same number, which is 0 0 0, and it will display 1. So technically it's repeating the same pattern, which is the same IC number. So that's all from me. Thank you. Assalamualaikum warahmatullahi wabarakatuh. My name is DANIAL bin Rosli, and today I'm going to simulate to you the result when the switch at SD1 is pressed. So, little disclaimer, this is a pre-recorded video, so I will play the video and we can see the result. So from here we can see that only switch at SD1 is only on, so we can see top and the center, so it will display the pattern like this, and it will go back to its original pattern, so in the middle and at the top one. So after complete this cycle, it will play once again the same pattern. Yes, so we can see the top and in the middle, so there will be only two in the middle, and same, it will go back to its, yes, that's, this is the pattern for the blinking LED for our group. That's all for me. Thank you. Next, I will simulate to you the result when the SD2 is pressed. Technically, it will display our group's leader IC number. So I will play the video. This is a pre-recorded video, so I will play the playback speed. I will increase it, so the speed will be much faster. So you can see 1 2 0 0 1 0 0 1 2 0 1 2 0 5. It will display a 12-digit number because according to IC. So it lasts with the digit 9. So next it will display, it will repeat the same number, which is 0 0 0, and it will display 1. So technically it's repeating the same pattern, which is the same IC number. So that's all from me. Thank you.
So I will explain about the simulation for task 4, which is the addition, subtraction, multiplication, and also the division. So here is the simulator. So I will run it, and then we turn off all the switch on port D except for the PD3, which is the SD3 switch. And then we turn off the toggle, but before that we assign the value for num-B and num-A. Num-B, which is the PA7 until PA4, we assign it as num6, and then we assign the num-B, which is PA3 until PA0, we assign it as num2, value of number 2. Then we turn off. So here we get the result. 6 plus 2 is 8, and then subtraction, 6 minus 2 is 4, and then 6 times 2 is C, which is 12, and 6 divided by 2 is 3. So let's try another value. We make it as 2 times 2. So I mean 2 on number A and 2 on number 2. So here we get right. First 2 plus 2 is 4, and then subtraction, 2 minus 2 is 0, and then 2 times 2 is 4, and the last one is 2 divided by 2 is equal to 1. So that's all for task number 4.